Automation is often a big investment deemed not worth making in a CNC machine shop. Today, I'll show you how designing in some flexibility can make automation possible with quantities of less than 10,000 parts per year. Automation that is skillfully implemented should significantly change the daily tasks of employees. It also massively reduces labor costs on a cost per part basis. These benefits are mainly achieved by enabling unmanned operation of CNC machines. Of course, there are still processes that need human intervention, so the introduction of automation does not eliminate employees. Processes such as quality control, changing inserts, changing tools, maintenance, and setting up for different jobs may still require a human touch. The day-to-day reality is that the machine will operate most of the time on its own in an automated fashion, but it will still need a human to fix things that go wrong from time to time. This enables you to run more automated cells with the same or fewer staff, but in general, the employees need to be more technical. The tasks will be more interesting, making it easier to maintain talent. Overall, this will significantly decrease the labor involved on a cost per part basis, which works to justify the capital expenditure of introducing automation. Higher productivity. The second area where shops will experience a return on investment is the ability to run longer operating hours. Machines don't sleep, and as a result, you can run overnight during hours where it would be normally difficult to find operators. You can also run during weekends. Some production facilities may even find that they have to pay night or weekend premiums to maintain staff during these shifts. With a robot working these shifts, you can save on those night premiums, as well as the difficulties of finding staff that will show up for these undesirable shifts. Automation also saves employees from maintaining an unpleasant schedule, and I am sure that it saves many people from experiencing sleep disorders, as they are often experienced by shift workers. In order to get an automated cell to run during these hours, it is very important to prove out the reliability. This involves designing fixtures and movements that allow for the accurate and repeatable placement of materials in the work cell. Advanced logic that ensures the robot understands how to deal with situations that may arise. Significant amounts of testing to prevent unwanted collisions between the robot and other machines. Gathering data and understanding the tool wear in the application. Planned tool or insert changes, appropriate use of wear compensation, tracking the status of each part. For example, the robot needs to understand which parts have been processed with both OP1 and OP2. Consistency, quality, and rework. We can further increase our return on investment by reducing rework while simultaneously increasing the quality and consistency of our parts. For example, a robot can be tuned to place a part into a lathe chuck with less reno than a human operator. The consistent placement of the part in the machine translates to more consistent parts and therefore less rework and wasted materials. Building in flexibility. Automation is a necessity to stay competitive in a global market because it reduces costs on a per product basis. Unfortunately, automation can also be capital intensive. One view of automation is that it is great at mass producing consistent, high quality products, but that it is inflexible. In other words, once an automated cell is programmed to produce one product, it is very consistent at producing that one product, but retooling is difficult. This is not true today. Automation technology is becoming increasingly smart, programmable, and flexible. With some skill and a little imagination, automated work cells can be retooled in a matter of hours to handle different parts. In addition, the cost of good quality robots will continue to decline over time. This means that the minimum volumes can be much lower than 100,000, 10,000, or even 3,000 parts per year. The minimum volume of parts required to justify an automated work cell is still significant. That number, of course, will change depending on the margin earned on each part in your business, but it is possible to combine many similar parts to justify the cost of the automation, the machines, and the floor space. And it is the flexibility of automation technology today that allows us to produce multiple different part numbers out of the same work cell. For example, instead of having to sell 10,000 of one part number to experience the benefits of automation, you could combine 3,000 of part A, 3,000 of part B, 3,000 of part C, and 1,000 of part D per year, which are already volumes that you're selling to your customers. This would allow you to start automating today and reach a 2-year payback period on the automated work cell without selling additional volumes to your existing or new customers. Of course, there are some limitations that you should be aware of. In order to produce multiple part numbers out of the same machines, the parts must be compatible with the capabilities and capacities of the machines in the work cell, such as the lathes, mills, engravers, laser markers or grinders, and the load capacity and reach of the robot. Other than that, fixtures, magazines, and other implements for organizing and handling the materials can be changed and swapped out easily. In the past, we've helped with the automation of mass custom manufactured products, such as dental aligners, where every product is customized to each customer and every tool path is unique. And in the automated work cell that you have been seeing clips of in this video, we program the cell to handle any part that can be made within a range of raw material sizes and this CNC lathe mill combination. Adding new parts to this automated work cell requires new CNC programs and perhaps a slight change of tooling, but on the robot side, a simple configuration file and a little testing is all it takes to handle material for parts that have completely different features. Since automation is CapEx intensive, one of the best ways to maximize your returns is to ensure that the automation is flexible and that it can be easily repurposed. I hope you found this video helpful and informative. If you want to learn about end-of-arm tooling and examples of how it is used in almost every industry, click the link in the description below. Please like, subscribe for more content like this, and share the video with someone who will benefit from viewing it. I'm Stephen Bruce Wong from Automation Experts. Thanks again for watching, and I'll see you in the next one.